This is A. Radhika. I am going to give a video lecture on power electronics. Today we are going to discuss about the choppers. Under that we are going to discuss about the working principle of chopper and classification. So here in previous classes we discussed about the uh, three-phase full wave control converter with R load and input output waveforms for R load, deviation of average DC output voltage with R load, derivation of average DC output current with R load. Today we are going to discuss about the working principle of chopper, how the load voltage and current can be changed using a chopper. So before going to this one, just we are discussing actually what is the chopper. So here, so in this the chopper is nothing but it is a static device, means static switch used to convert fixed DC voltage to variable DC output voltage. These are mainly available in two types by the process of conversion, namely AC link chopper and DC link chopper. And also we have the step up and step down choppers. So before going to discuss this one, we are going to discuss about working principle of chopper. So this is the circuit diagram of chopper. Chopper is the elementary chopper circuit. In this chopper we have the supply voltage, one chopper. The chopper works like switch and also it will be connected with the freewheeling diode. The freewheeling diode bypasses the current. It has the output voltage and also it will be connected inductance. The to the load, the current will be load current I naught. So in this the basic chopper circuit shows a chopper is a high speed on or off semiconductor switch. It connects source to load and disconnects the load from source at a fast speed. Hence, a chopped voltage is obtained from a constant DC supply. For low and medium power ratings, transistors are used as a switch, while for high power applications, thyristors are used. The working is the chopper is represented by a switch, SW means switch, which may be turned on or turned off as desired. During the period T on, the chopper is on and the load voltage is equal to source voltage Vs. During the interval T off, chopper is off. Load current flows through the freewheeling diode FD. Therefore, low terminals are short circuited by FD and load voltage becomes zero. Hence, a chopped DC voltage is produced at the low terminals. The waveform of load current is, it will be shows in the waveforms like here. Here is the waveforms. So here average load voltage V0 is equal to turn on time by turn on time plus turn off into Vs, that is V naught is equal to T on by total time into Vs, that is the alpha Vs. Alpha means is the chopping, alpha is the duty cycle, that is T on by total time T, and total T is equal to T on plus T off, that is the chopping period. Here T on is the on time, T off is the off time. Finally, the output voltage V naught is equal to F into T on Vs. Here F is equal to 1 by T, chop, that is the chopping frequency. Hence, from the voltage, from above equation V naught, the load voltage can changed by varying the duty cycle alpha or by varying the chopping frequency F. Here in this is the circuit diagram for chopper circuit. This is the circuit diagram for chopper circuit. It has the one chopper. The chopper will works as a switch. We are using on and off purpose, and it will be connected the freewheeling diode across the load, and it has the inductance. In this, chopper is also a high speed on off switch, means the chopper works as a switch, means it will be off or on. Chopper is a semiconductor switch, it is a semiconductor switch. So in this, it consists of it connects and disconnects the load from source at a fast speed. Means the chopper works as used for fast speed action. The chopped means variable voltage is obtained from a constant DC input supply. For low and medium power ratings, transistors are used as a switch, while for while for high while for high power applications, thyristors are used. So these are the output voltage and current waveforms. So the first one is the output waveform, and the dotted lines is the uh, supply voltage. And here the chopper will be works as turn on and turn off. In turn on time, this is the turn on time period, and remaining period is the turn off time. The cycle will be repeats, and this is the I naught output current that will be continuous. Here when the thyristor will be turn on time, that will the current will flow through the chopper, and also when the thyristor is turned off, that time also the current will be flows when the thyristor is off. Due to this reason, we are using the freewheeling diode for continuous power supply. The chopper is represented by a switch. It may be turned on or off as desired. During the period T on, the chopper is on and the load voltage is equal to source voltage. During the period turn off, the chopper is off and the load current flows through the freewheeling diode FT. So here, in this, therefore, load terminals are short circuited by freewheeling diode and load voltage becomes 0. Hence, a chopped voltage is produced at the load terminals. The output voltage and current are shown in this waveform. The average load voltage V naught is equal to T on by T on plus T off into Vs. So T on by T into Vs. So T means turn off time and turn off turn on time and turn off time of the thyristor. This is called chopping time period, and alpha is called T on by T, that is the duty cycle. Here T on is the on time and T off is the off time of the thyristor. In this, therefore, output voltage is equal to F T on into Vs. Here F is the 1 by T, means chopping frequency. Finally, the load voltage V naught can be changed by varying the duty cycle alpha or by varying the chopping frequency F. Here a chopper is a static switch used to convert fixed input DC voltage into variable output DC voltage. The chopper is a static switch used to convert fixed input DC voltage into variable output DC voltage. Actually, the types of choppers. According to process of conversion, there are two types, that are AC link chopper and DC link chopper. Here in this, according to process of conversion, there are two types, that are AC linked chopper and DC chopper. According to magnitude of output voltage, there are two types, that are step up and step down choppers. In types of choppers, in flowchart form, the choppers will be AC linked choppers. Under that we have step up and step down. Again in DC choppers, it will be again step up and step down choppers. In AC link chopper, we have the input DC inverter. The inverter will be converts DC to AC. Again the converter converts AC to DC. Finally input and output is DC to DC, that is the AC link chopper. In this, in AC link chopper, DC is first converted to AC by an inverter. AC is then step up or step down by using transformer, which is then converted back to DC by using diode rectifier. In this, these choppers requires two stages of conversion, and hence choppers are costly, bulky and less efficient. So in this AC link chopper, the fixed DC is first converted to AC by an inverter. The converted AC is then step up or step down using transformer. Again this AC voltage inverted to DC voltage using a rectifier. It has disadvantages using of AC linked chopper, that are the AC linked chopper requires two stages of conversion. They are bulky in size, they are costly and they are less inefficient. Now we are going to discuss about the DC chopper. This is the diagram, and the DC chopper will be directly converts variable to fixed DC voltage to variable. The DC chopper is a static device which converts fixed DC voltage to a variable DC output voltage. The applications are, the choppers find many applications, namely trolley cars, marine host, speed control of motors, traction motor control, battery operated vehicles, forklift lights. Maximum the choppers are used where the working is on and off. So the chopper will be works as a switch. Control methods of choppers. In voltage control method of chopper is two types. First is the variable frequency method and second is the constant frequency method. So in this first one, DC chopper, a variable frequency control method. The chopping frequency F can be varied by varying turn on, keeping turn off constant, by varying turn off, keeping turn on constant. Here duty cycle alpha changed when T changed, hence the average output voltage and current changed. In DC chopper, by varying T on, keeping T off constant method. So in this we can observe two figures. First one, we have the turn off and turn on periods. The blue line indicates the average voltage and red indicates the output voltage. The total time is T on plus T off. In T on time, the thyristor will be conducts, the chopper will be conducts, and in T off time, the chopper will in off time. So here also same, but the duration is different. In the above figure, in first figure, the output voltage for duty cycle T on is equal to 0.6 T time, means here duty cycle alpha is equal to zero point 0.6, and also here alpha is equal to 0.7, the turn on time is equal to 0.7 time, total time. In DC chopper, by varying turn off, keeping turn on constant method, here also we have the two waveforms. In first, the blue line is the average voltage, the red line is the maximum output voltage. Here also T on and T off time, that is the total time. Here also the gap means T on time is almost equal to T off time. So here varying T off constant T on method graphs. In this, the first figure shows the output voltage for duty cycle. Alpha is equal to 0.6, that is T on is equal to 0.6 time. Alpha is equal to 0.45, that is T on is equal to 0.45 time, total time. We know the total time T is equal to T on plus T off, and by changing T on or T off time, the time period total T is changed, and hence it is a variable frequency method. Now the DC chopper B constant frequency control method. In this, the chopping frequency F can be constant by varying turn on time T on. Here the duty cycle alpha is changed when T on is changed. Hence, the average output voltage and current are changed. In this, we have the again two waveforms. In these waveforms, we have the average voltage in blue line and in red line maximum output voltage. The chopper will be on and off, that is the total time. And here the compared to first waveform, here the turnout time is less. Varying T on the T constant method graphs. Here in first waveform, alpha is equal to 0.6, the turn on time is equal to 0.6 time, total time. In case of alpha is equal to 0.8, the turn on time is equal to 0.8 total time. T is equal to T on plus T off, and either T on or T off is changed, but time period T is kept constant, hence it is a constant frequency method. So here now we can watch one YouTube video regarding choppers.
Today we are going to discuss about the DC to DC converters. So the DC to DC converters are also called as choppers. So in the previous week, on the last week, we have discussed about the basic components which are used in the power electronics like power BJT, power MOSFET, IGBT, all those videos. Now in this week we will be discussing more on the choppers or converters. It is DC to DC converters. We will be discussing step up, step down, basic choppers, which are operating in first quadrant, second quadrant, and also in all four quadrants. All these things we'll be discussing, and also we'll be discussing the buck converter, boost converter, and buck boost converter. Okay, so these type of topics we'll be discussing mostly in this week. Okay, so in this video we'll be mainly discussing about the basic idea of DC to DC converters, which are choppers, and also we'll be discussing what are the main classifications and also the circuit diagram and working. Okay, the basic chopper working. Okay, now there are again a lot of variations based on which the working will also vary, that we'll be discussing in the upcoming videos. Okay, so what is a DC to DC converter? We have actually heard AC to DC converter and DC to AC converter. Now what is this DC to DC converter? DC to DC converter means here you are going to give a fixed DC input voltage, and it will chop, the circuit will chop your DC input voltage which is fixed, and you will be getting a variable output DC voltage. Okay, so input and output both are DC values only. Here input and output both are DC, but input is a fixed one, output will be variable. So you will get a chopped version of your input. Okay, so that is a basic idea of a DC to DC converter. And due to this chopping or due to the variations happening in the fixed DC, we know that DC means it is a fixed value, but output is a variable DC. So due to this variations or due to the chopping, we call these circuits as choppers. Okay, I hope the basic definition is clear to you. Okay, so the chopper can be actually considered as DC equivalent of a AC transformer. Okay, you can think of a chopper as a DC equivalent of, I'll write it here. So it is a DC equivalent of an AC transformer. You can think of a chopper like this. Okay. Now how this chopping is actually done? So if you observe the circuit of a chopper, it is nothing but it is a high speed on off semiconductor switch. So in a chopper circuit, there will be a high speed operating semiconductor switch, and this semiconductor switch, when it is operating in a high speed, that is on off, it will be happening at the high speed. So it connects the source to the load and disconnects the load at a high speed. So we know that there is a source side and then there is a load side, right? So the load and the source are connected with each other and disconnected, and this connection and disconnection is happening at a very high speed. Okay, so that's why the chopping is happening. Okay, so this circuit will be having a high speed on a semiconductor switch, and with the help of that switch, the source and the load side are connected and disconnected at a very high rate or at a very high speed, and due to which the voltage is actually getting chopped. Okay, I hope the basic concept is clear. Now, in order to, I just now told you that there is a switch present, and the switch we are using here is actually a SCR. Okay, SCR is a silicon control rectifier. We have actually done videos on silicon control rectifiers last week, the basics, everything. So the one of the very important use or application of an SCR is it can be used as a switch. In a lot of circuits, we use SCR as switch. Okay, and also this SCR is having a lot of applications, especially in the power electronics area. Okay, so anyway, in the choppers, we are using silicon controlled rectifier switches, and this SCR is triggered on and triggered off at a very high speed. Okay, the switch has to operate at a very high speed. So the SCR is turned on and off at a very high speed. And this is how the connection and disconnection of the load source is happening. Okay. And also by varying the on and the off time of SCR, we can actually vary the voltage that is coming across the load. Okay, so based on by varying the time of on and off, that is on time and off time of this SCR switch, you can vary the voltage coming at the load side. Okay, so this is the basic working principle of a DC to DC converter. Again, we are going to see the circuit diagram. With the help of circuit diagram, we will be again discussing this basic choppers. That is basics of choppers. Anyway, this is the basic thing you are going to see in the circuit diagram also. Okay, now coming on to the applications. Actually, this choppers has a lot of applications, especially for DC motor control and also for computer power supplies, in commercial electronics devices, in electric cars. In all these areas, the choppers or DC to DC converters are being used. Okay. Next, we are going to see the circuit diagram of a basic chopper, and with the help of that circuit diagram, we'll see how the chopper is actually working and how the SCR is connected. Everything we are going to see. Okay. Next, we are going to see the circuit diagram and the working of a basic chopper. Okay, so this is not step up or step down or anything. This is a basic chopper. Okay. Now, if you want to study step up and step down, please do stay tuned to the channel. We'll be doing the videos on step up, step down, buck converter, boost converter, all these topics very soon. Okay, videos will be uploaded very soon. So the basic circuit diagram, if you don't know anything about chopper, you should know that this is the basic circuit diagram of a chopper. Now if you don't know what is actually a chopper, you can actually think of a chopper as a switch. Okay, it is just a switch with some additional components. Now the switching action is actually performed here with the help of this SCR. So you know that this is the symbol of SCRs. Okay, so this symbol of SCR, or this is SCR, is actually performing the switching action here, and this entire circuit is performing nothing but switching action only. It is not performing any other things but just switching, that is on off likewise. Okay, so the basic circuit diagram is actually consisting of, there is a source side, this is source voltage is Vs, there is a load, and across this load we'll be getting our output voltage. There is an inductance, there is a freewheeling diode. In some circuits there will be freewheeling diode, in some circuits there won't be. While discussing the step up and step down, you will get to know more details. Okay, and this is the switch, and with the help of this thyristor, this SCR or the switch, the circuit is actually getting connected and disconnected. Okay, so this switch is actually operated at a very high speed or in a very fast way, and we know that for SCR there is SCR triggering mechanisms, right? Triggering on and triggering off. So the triggering mechanisms are used here to turn off and off this device or this SCR, and hence the circuit is actually working. But in the circuit diagram, we are not actually drawing the triggering mechanisms and all to avoid complexity. Okay, so you should know that this is the basic working of a basic structure of a DC to DC chopper. Okay, now let us see how the on state and off state is varied here. So this is the circuit diagram for on state. Okay, I hope you can see it very clearly. So this is the circuit diagram for on state. Okay, so during the on state, you can see that the switch is in the on condition, so it is as it is, and there will be a circuit like this. Okay, so when the chopper or when the DC to DC converter is in the on condition, you will get the Vs voltage entirely across the load. Okay, so here we are not actually considering any amplification in the voltage value or any increase in the voltage value or anything. So whatever Vs value is there, you will get across the load during the on state. Okay, so during the on condition, the load voltage will be equal to Vs. So I can write it here. So load voltage will be equal to Vs in this state. Okay, now during the off state means the switch is in the off condition. So what will happen when the switch is in the off condition means there is a open circuit. Okay, now there is actually no connection happening between the source voltage and the load voltage, right? So during the off condition, the load current will be actually flowing through this freewheeling diode. So here you can see that there is a short circuit actually formed here. The connection with the source side has been disconnected with the help of the switch, and there is a short circuit formed here. Okay, so the load current, it will flow through the freewheeling diode like this. Okay, and as a result, the load terminal will be short circuited by the freewheeling diode and the load voltage is equal to 0. So I can write here load voltage is equal to 0. Okay, 0 volt is the load voltage. Okay, so this is how a DC to DC converter or a basic chopper is working. Now, how can you find the average voltage? That is how can you find the average output voltage? The equation is given like this. V out is equal to T on by T on plus T off into Vs. Okay. So the equation is V out, the average output voltage. The average output voltage is given by on time plus off time into Vs. Now this T on time or this T off time is actually the time of owning and off of this SCR. Okay, so the time period for which the SCR is turned on, the time for which the SCR is turned off, that time is actually the on time of the chopper circuit or the off time of the chopper circuit, right? So that is T on and T off. Okay, so the average voltage is given by V out is equal to T on by T on plus T off into Vs, or you can write it as T on, that is on time by total time. This is the total time into Vs, right? And you can take this T on time by T as alpha, which is the duty cycle. Okay, so here we are taking this as alpha, which is equal to duty cycle. So you can write it as, that is the output voltage V out is equal to alpha times Vs. Okay, so you can write here, I'll remove it. So V out is equal to alpha times Vs, right? So you can clearly understand that what all things the output voltage is depending on. Output voltage is depending on the supply voltage Vs and also the duty cycle of the chopper. Okay, so duty cycle is given by on time by total time, and it is taken as alpha, that is a duty cycle. So V out is depending on the duty cycle and the source voltage. Okay, so these are the two factors on which the output voltage of a chopper is actually depending on. Now based on this relation, we are actually designing step up, step down, all those choppers. Okay, so this is how the circuit of a chopper is looking like, and this is the working. Okay, next we are going to discuss about the classification of DC to DC converters or choppers. Now here the classification is actually done based on the output voltage level. Okay, again there are other classifications based on the triggering mechanism of the SCR and all, but here we are only discussing the classification based on the output voltage level, whether it is higher or whether it is lower, likewise. Okay, so you can classify the DC to DC converter or choppers as three categories based on the output voltage levels. First one is step down chopper, then step up chopper, the last one is step up down chopper. That means it can be both. Okay, step up and down chopper. Okay, so we'll discuss what are the basic things of these three. Anyway, we'll be doing detailed videos on this. Okay, so the first one is step down chopper. So step down means here in this case the average output voltage will be less than the input voltage. Okay, it can also be known as step down converter. Okay, step down chopper or step down converter. So the output voltage I'm going to take it as V out. V out is less than the source voltage. So the average output voltage will be less than the source voltage. Now what will be the condition here? Clearly the opposite one, right? So for the step up chopper, the average output voltage will be more than the input voltage. So Vs is the source voltage, which is the input. Now for step up and down converter, this type of converter produces an output voltage which can be either lower or higher than the input voltage. Okay, so here V out can be either greater than or Vs, or it can be less than Vs. It can be either ways. Okay. So these are the three basic classifications of choppers. So I'm hoping that you understood the concept of chopper. So this video was actually meant for those people who have not yet actually heard.
Now we watched the YouTube video about the working principle and the classification of choppers. Now today we discussed about the working principle of chopper, average load voltage V naught, chopping period T, duty cycle alpha, and chopping frequency F. Now we have here few quiz questions and frequently asked questions. So today this is the today class. Next class we are going to discuss about the classification of choppers. Thank you.